Good morning. My name is Jenna Carpenter, and I am the president of the Mathematical Association of America. It is my pleasure to welcome you this morning to the MAA-AMS-SIAM Gerald and Judith Porter Public Lecture Series, funded through the generosity of Jerry and Judith Porter. We're particularly honored to have Jerry with us today. This lecture series highlights speakers who combine mathematical distinction with an exceptional ability to communicate ideas to a broad audience. The Porter Lecture reflects a shared commitment to public engagement, showcasing mathematics as a vibrant and accessible discipline with deep connections to science, culture, and everyday life. It is my pleasure to introduce this year's Porter Lecturer, Étienne Ghys. Ghys is a mathematician and emeritus research director of CNRS at Ecole Normale Supérieure de Lyon. Ghys is known for his research in dynamical systems, geometry, and topology. In addition to this influential work, he has played a major role in making mathematics accessible to the general public. Known for his ability to explain sophisticated ideas using clear language, visual intuition, and historical context, his lectures emphasize understanding and curiosity, helping his audiences see mathematics as a creative and human endeavor rather than purely an abstract one. Ghys is also permanent secretary of the French Academy of Sciences, where he actively promotes public outreach and science education. He has collaborated on mathematical films and animations like Dimensions, as well as TV series and documentaries, many of which are used in schools and public exhibitions. Ghys has received many of the highest honors in mathematics, including the CNRS Gold Medal, recognizing both his research achievements and his broader impact on the mathematical community. We're very pleased to welcome him today to speak on the shape of letters, from Leonardo da Vinci to Donald Knuth. Please join me in welcoming Porter Lecturer Étienne Ghys.
Thank you. Thank you for being here. I'm greatly honored to give this Porter Lecture. I heard that Jerry Porter and Judith Porter were great people. Judy Porter, who is famous for having worked a lot as a sociologist on equality in gender and race. And she also worked hard on the sociology of AIDS. As for Gerald Porter, he also was very much concerned during all his career about diversity. I think that generally it's a wonderful example that they show us. So thank you to both of them. I just mentioned, as you can see on the slide, that Judith passed away not so long ago, so we remember her today. You know, geometry is about shapes, understanding shapes, looking at shapes. And in geometry, you do not have only squares or circles or simple things. You also have subtle, you also have shapes that you do not quite understand, sometimes because they are too small. And I want to discuss today, as you understood from the title, tiny little gems that we never look at carefully, letters. Look at this letter and several variations on the letter S. I'm pretty convinced that most of you have not looked at these shapes carefully. Many shapes, many different shapes for S, which look the same, but are not the same. For some reason, we do not look carefully at these shapes of letter, and I believe that this is an important thing because the way the letters are drawn is important in our understanding of many things. Could be text, could be mathematics, could be anything. This one is the most beautiful, I believe. And then I want to express how I got interested by that. More than 20 years ago, I was correcting the proofs of a paper of mine, which was supposed to appear in a prestigious journal. And all of a sudden, I realized that one letter I was printed upside down, with the I below the line, the dot of the I below the line. So I was really surprised, and I asked the editor-in-chief of the journal, how is it possible with a modern computer to print a letter upside down? And the editor-in-chief was a great mathematician who passed away now, Jacques Titz. He was so happy with my question. He told me, look, you have to know that this journal is the last mathematical journal in the world which is still using old-fashioned Gutenberg-style letters in lead. And sometimes the machine will just invert one of the characters, and this is why you have seen a reverted I. I was really happy, and he said, please close your eyes and run over the paper. You will feel the shape and the relief that printers call the embossing. And he was so happy with this old tradition of good printing, of beautiful printing. So I was really amazed, and I don't know if this is because I was amazed, but the next week, Jacques Titz asked me to take his place as editor-in-chief of the journal. I like that very much, like transmitting something, tradition. I like tradition. And when Jacques Titz got retired, there was a big colloquium in Collège de France for his retirement, and he received a gift. The gift was a metallic copy of 6 pages of this journal in lead. Very heavy, he couldn't even weight them. Actually, I like the idea that culture and mathematics has a weight in kilograms. And you know, you probably remember when you were 5 or 6 years old, you probably remember that learning how to read or to write, recognizing letters, was the hard work. But once you understood it, we forget it. Just like when we walk, we do not think about our feet. It became something which is totally subconscious. Initially, you have high conscience, it's hard work. And then it becomes something you don't even think about it. And this is why we usually do not look at letters in detail. Look, neuroscientists know today where the letters are in your brain. There's a place like here, about 1 cubic centimeter, where the shape of letters is located. And it's subconscious. When you learn how to read, it's on your the frontal part of your brain, and then it migrates there. So I think it's rather interesting to know that letters are beautiful, are very important for our understanding, but we keep forgetting them, just like we keep forgetting our feet. Okay, so now, today, I want to explain, I want to describe a long story, 500 years. So I have to make things short. I have to make choices. I've decided to choose 4 important moments in this history and 4 important personalities. I will show you them now. You may recognize them or not. Did you recognize him? Did you recognize him? And the last one is known by all mathematicians. So, okay, so let me begin by the first one, Gutenberg. Gutenberg invented printing around 1445 or 1450. But you have to know that he was not a mathematician, he was not a designer, he was not an artist, he was a businessman. He wanted to make money out of printing Bibles. He wanted to create Bibles which would be similar to the handwritten manuscripts of the Bible. His idea was that he would produce books that look so close to the very expensive books created by monks that he could sell them much cheaper. Actually, he went bankrupt. But anyway, this is a very important moment in the history of culture. The invention of printing changes everything in our world. You have to understand that the main contribution of Gutenberg is not technological or whatever. He transformed a concept, the concept of letter, which before him was just abstract, a sign. He transformed these abstract signs in concrete objects made out of metal. So the letters all of a sudden became material objects. Here is a punch. I believe that those of you who are less than 50 years old have probably no idea of how one printed books 40 years ago. Nevertheless, the way of printing books has been basically the same during 500 years. A few minor improvements appeared, but basically the same idea. So let me explain how to do that quickly. First, you need a piece of steel, very hard steel, in which you engrave a character. Like here, the letter N. Be careful, this letter is very small. So you have to do this work. This is very complicated. You have to be a very good craftsman or even artist. More or less, to get this object, like 2 millimeters high, you need about 1 week of work. And you have to do that for each letter, for each size. So in order to get the full set of letters, it takes you a huge time. It's very expensive. It's something very, very important. Then, once you have this punch, you use it to strike it against a softer metal to get something which is a hollow print. It's called a matrix. Here you have a matrix of one font I will describe later. The punch is something very valuable. The matrix, you can make another one if your matrix is damaged. You can make another one. And then you have a third step, which is the following. Molten lead is poured into the hollow to create a huge number of small metallic characters. So you have this big box, a case. You put these letters in the box, uppercase or lowercase, and then you can use these letters to connect them and to create what's called a form. Here's an example. It's a metallic form. I chose as an example the gift that was made to Jacques Tits. It's something like that. It's, of course, a mirror image of what you want to print. And to convince you, I took the mirror image of this, and you have, you can see, Publications mathématiques, Jacques Tits, Jean Bourgain, Pierre Deligne, Misha Gromov, Maxime Kontsevich, Dennis Sullivan, and René Thom, which are quite good mathematicians. Anyway, so that's the way Gutenberg produced books. Here's the list of the font that Gutenberg used. He had 290 different sizes and shapes for letters. You see, it's almost impossible to read. These characters are small, not legible. It's something which is very impossible to understand. As I told you, that was not his motivation. He wanted to do something like looked like the handwritten books. Okay, now here's an example of the Bible, called the Bible in 42, because each page has 42 lines. It's a beautiful object, but try to read it, you will not succeed. Next of my hero is Leonardo da Vinci. Well, be careful, this picture is maybe not Leonardo da Vinci. We don't have any significant proof that he might be the young Leonardo. Anyway, let me think it is Leonardo, because it turns out that he was, you will see in a painting where historians think that he might be Leonardo. We are now at the end of the Middle Age, at the beginning of Renaissance, and printers and humanists wanted to come back to the original culture of the Latin culture. And then one of the best model they had is this kind of writing that you find on the Trajan column in Rome. These letters are just wonderful. They look like you can read them. It's understandable. It's much better than what was originally in the Bible of Gutenberg. Anyway, so that was the significant model that all humanists wanted to copy. And here's the painting. You see the serious mathematician, a monk. His name is Luca Pacioli. Luca Pacioli is no doubt a very good mathematician, exceptional mathematician. And behind him, his student that historians believe it might be Leonardo. Anyway, you can see many proofs that this is a mathematician. You see on the table you have a compass. He's writing something on like a geometrical figure. You can maybe even see the name of Euclid somewhere, and you see on the top this object, which is a Rubik compactahedron, an Archimedean solid. This is a wonderful painting, and the point is that he wrote a book, a wonderful book called The Divine Proportion. It's a math book, no doubt. However, at the end of the book, there is a succession of beautiful pictures. And we know today, there is no doubt, that these pictures have been drawn by Leonardo. And the point is that the most important pictures is an alphabet drawn by Leonardo. Let's have a look at some letters in this alphabet. You see, it looks like geometry. Huh? It looks like high school geometry somehow. You have circles, you have lines, and for each letter there is a small description below the picture, a small description of how to draw the letter. The description is not complete, but it gives you some idea of how to draw the picture. This is A, B, C, Q, more complicated. And finally, I put the S because I will explain to you later that the S is the most complicated letter of all. So that's a beautiful book. You can find that on the internet with no problem. And I want to emphasize the fact that maybe not Leonardo. Leonardo was not a mathematician, but at least Pacioli was very much influenced by a mathematical book, which is the Elements of Euclid. The Elements of Euclid have been written 200 or 300 years before Christ, but they had been translated in Latin rather recently, and Pacioli himself had his own translation. And on the picture I showed you earlier, his left hand is on the Bible of mathematician, the Euclid. And here's one of the pages of the book of Euclid as translated by Pacioli. You see, you don't even know if it's a text or picture. Picture or text, not clear. Myself, when I open a book, a mathematical book, I first look at pictures. It's easier for me to understand. It's not clear whether or not the old books from antiquity, the pictures are there to explain the text, or the text is there to explain the picture. That's a fundamental question. Anyway, just after Pacioli and Leonardo, some other artists or humanists did something more important, more significant. You have here another monk, Francesco Torniello. He wrote a book, Opera del modo di fare le lettere maiuscole antiche. And in this book, he gives precise instructions to draw each letter. You have here the letter S, once again, with detailed instructions to construct it. To show you how to do that, I copied it myself on the left using one of these softwares that are very common in France, at least for high school students, called GeoGebra. I don't know if it's famous here, but this is fun. So, taking the book of Torniello, looking at this picture and copy it, and you get the picture on the left. But he's not the only one. Another one, famous one, is Dürer, probably one of the most important artists in all history. This guy was an artist, but he was a mathematician. When you read the books of Dürer, you see that he is explaining how to draw a regular pentagon and a regular decagon and trying to draw a regular heptagon. He's a fantastic mathematician. And he wrote this book on the just shaping of letters. Here's an example of a page. He also drew an alphabet and two alphabets. You see two copies of B. And then it's interesting because he says, well, the Euclid geometry is not enough. A ruler and a compass are not enough to draw beautiful letters. He says, for example, he writes, the balls of the letter B should be fuller at the bottom than at the top. And they are as they are when written with a pen. And that one must sometimes complete the drawing by hand. So he says, you know, there is something more than the rigidity of the ruler and the compass. We need hands. That's a good idea. Okay, next hero. Did you recognize him? Louis XIV. In the middle, and on the left part of the picture, Colbert. Colbert was the prime minister. I will tell you towards the end of my talk I will tell you is the influence of politics on typography. And Louis XIV was the most important king in the history of France. He wanted to centralize everything. And this is why France is centralized today again. And he, in this picture, in this painting, you see a presentation of the Académie des Sciences, of the Academy of Sciences, in 1666. And what happened is that Louis XIV commissioned a font to the Académie des Sciences. He wanted a font that would illustrate his power. So the question was, please construct something, a new font that would be the image of my concept of a centralized power as it was at the time. And I think it's quite fascinating because a group of 5 or 6 scientists, artists, began to study scientifically how could produce scientific letters at the image of Louis XIV. So that's I like it because they began by creating the concept of pixel. Until then, nobody had the idea of drawing a picture or a letter on a square, which is subdivided in 2,304 pixels. And so they began to work. It took 10 years. And after 10 years, they produced these letters, which I think are beautiful, a bit rigid. But they are beautiful. Look at that, the letter G. And what happened is that this font became compulsory for all official production, all official printer in the French kingdom had to use this font. And let me give you an example and an anecdote. When they produced their font, they realized that there was no difference between a capital I on the left and a lowercase l. They looked the same, they were identical. So the only thing they had in mind was to invent some kind of additional spur to distinguish the lowercase l to the capital I. And that's today, it's kind of, you can recognize immediately a text which is written in this font. This font is called Romain du Roi, the Royal Roman. And it was important in France during at least 100 years. You immediately see that this is the right font because of this little sign. For example, you have here a mathematical text produced by the French Academy. And if you look carefully, you see that all the L's have this, this significant small sign. Look, look, look. You see here, le premier, you see the little sign on the left. Anyway, it was, I think, one of the first time politics entered into typography. I will show you some other examples later. And then I have to skip many new ideas. Let me show you some names. You all know these names. They are in your computer when you select the font for your Macintosh or whatever. You see these names which are famous, but you have to know that behind these names, there were mathematicians, there were artists, designers. French one, Garamond, Italian one, Bodoni, a French one again, Didot, and an English one, Baskerville. And typography became a science with a huge quantity of strange names to explain the shapes. I will not discuss that, but you see there are many different ways of drawing letters, and you see bowls, ascender, crossbar, etc., etc. But allow me to skip some century and come to the next hero, Donald Knuth. That's an interesting story. I think most mathematicians know his name, but not so many know how he began to work on typography. The thing is the following. He had written a book, which is called The Art of Computer Programming. Please read this book. This is a wonderful book, not only from the artistic point of view, but from the mathematical point of view. It's a mixture of computer science and mathematics, several volumes, 4 volumes. If you read this book, you will not waste your time, I promise. But when he received the proofs of the second edition of this book, he was so disappointed by the quality of the printing that he said, I cannot continue in this way. Maybe some of you, those of you who are more than 50, remember that. You remember that, huh? And with these printers, noisy printers, but it was positive because in our homes, we could print in our homes, but nevertheless, these letters are awful. And what I understand is that he was upset. Donald Knuth was really upset. He said the following. Mathematical books and journals do not look as beautiful as they did in the past. It is not that their mathematical content is unsatisfactory, but rather that the old traditions of typesettings have become too expensive. Fortunately, it now appears that mathematics itself can be used to solve this problem. So he said, I'm a mathematician, I'm a computer scientist, these fonts are awful, the Roman du Roi is much more beautiful. Let me think as a mathematician how to improve typography. And this is what he did. As most of you know, he created 2 softwares. One is called TeX, that you all know. It's a different way of, it's not a software, it's a language. It's a different way of thinking how to write mathematics, like making a difference between the presentation and what you want to say. It's a fantastic thing. But this is not what I want to say. He created a MetaFont. MetaFont is a computer program to draw letters. That was like a revolution. Until then, letters were still punched in steel. And he tried to draw pictures of letters. And he said that the most difficult letter was the letter S. He did not succeed in drawing good pictures for S. And at some moment he said, it is so difficult to draw an S that I have decided I should rewrite my book without using S. And of course he did not do that. But nevertheless, he wrote a paper. Please read this paper. Even if you are a beginner, like a student, you read this paper. It's called The Letter S. It's fantastic. It's a paper where you recognize the S of Torniello. You see that the great Knuth had the idea of coming back to the tradition of the Renaissance, trying to understand the way they were thinking, and trying to add his knowledge of mathematics and computer science to create new letters. Reading this paper, you will learn history, mathematics, and computer science, and technology. When I met once Donald Knuth, I said to him, I love your paper with the letter S. And he was so happy because he told me that he believed that nobody had read it. But this is not true. Not only I read it, but all my students have to read it. Anyway, so he was somehow happy because at the same time, there was the creation of a new way of drawing curves on a computer, which is called the Bézier curve. I will explain that in a moment. Bézier was an engineer who worked on designing cars. And he had to draw pictures and lines and curves, and he created this concept that I will not explain to you in detail, but I want to explain to you the idea. The idea is this. This is my toy train when I was 10 years old, the exact same box, I remember. And you remember that when you had this kind of a toy, you could only create tracks which are straight lines or circles, exactly like Torniello. And you can imagine that if any train, any track would be created like that, that would be terrible. Because when you are on a straight line, no acceleration, and all of a sudden there is a circle, there is centrifugal force, you will receive sudden shock, like a Dirac mass of acceleration. So it's good for toys, it's not good for actual tracks. So engineers designing train tracks know exactly how to do. They connect the straight line in blue with the circular line in green with a very sophisticated red curve whose curvature goes slowly from 0 to the curvature of the circle. These curves have been studied for many years. They have a beautiful name. They are called clotoid. And this is exactly how this is done for actual train tracks. They connect straight pieces and circular arcs by clotoid. So this is the main idea, how to smooth curve. Actually, Dürer, I mentioned earlier, he was not so happy. He said, you have to use your hand at some moment. He was not happy because of that, because when you connect the top of the Torniello S to the beginning of the circle, your eye is not happy with that. There's a shock in your perception of the eye. So you have to do something better. And this is what Bézier did. So very quickly, what is it? You have 4 points, A, B, C, D, and you want to find a curve going from A to D, starting in the direction of AB and finishing in the direction of CD. And the trick, I will show you a formula. The only formula in my talk. It's a barycentric combination of the 4 points A, B, C, D, and the coefficients look strange. Whereas they are not so strange, because if you write y minus t plus t is equal to 1, you raise that to the third power, and you get the sum of 4 numbers, which is equal to 1, 1 minus 1 cubed plus 3 times 1 minus 2 squared. And you use these 4 numbers as barycenter's coefficients to get this curve going from A to B in the right direction at the point, with the right tangents at A and B. And if you connect several of them, you can connect these and create beautiful curves. And you can do that easily on your computer. And I'm sure many of you have already done that. When you use Photoshop or whatever, or any software proposing pictures, you have a way of drawing beautiful smooth curves. And they look smooth. They could be used by train tracks. And today, all letters are drawn in this way. Here's an E, for example. Here's an O. So if you want to remember one thing from my talk, please do not say that an O is just a circle. An O is a sophisticated diagram, it's a sophisticated picture. And there are several kinds of O's. And these O's have we have different perception of these O's. I will say a few things about that. Anyway, so what Knuth did, he understood that, and he realized that his fonts may be parameterized by parameters. And he created a font, not one font, not two fonts like Dürer. He created a font depending on 72 parameters. You can choose the parameters and change the size and the shape of the letter. And this is fantastic. So he did that. He never realized that, he never succeeded in transmitting his ideas to the official designers, because designers said a mathematician knows nothing about art. And he was somehow alone. And let me show you one thing that he did that I like very much. This is a piece of art. He wrote the Psalm of the Bible, the Lord is my shepherd, etc., etc. And look at that. The font is changing continuously from the first line to the last line. So he changes the parameter of the 62 parameters continuously in this way. I think it's wonderful. On the top, it's a very like Romain Duroy style. And on the bottom is like a modern font. I like this very much. I will show you some other things. So he tried to explain that. And there was a war between, I noted because I keep forgetting these names. You know, Adobe produced PostScript, Microsoft, Apple, TrueType, OpenType, and finally in 2016, they joined Google to create a variable OpenType, which is exactly that. So, of course, all these fonts by Microsoft, Apple, etc., are not free, and beautiful but not free. And in the case of Knuth, let me read what he said. I have placed the system in the public domain so that anyone, anywhere in the world, can freely use it. I have also spent thousands of hours ensuring that they produce essentially identical results in all computers. I am convinced that fixed system has great values. This is why I would not recommend to seek any improvement in tech. His idea is that our world is going too fast. We should slow down, and if you have a good system, use it and do not try to change it. For example, the tech has a number, the number of the version. Initially it was 3, then it was 3.1, and then it's converging to pi. And he has decided that after his death, the official number of tech will be pi. And he said that from that moment on, all the bugs will be permanent features. Anyway, so I like his personality very much. You know that Donald Knuth is not only a mathematician, computer scientist, he's also a good musician. He produced operas for. Okay, let me show you something else. Okay, so this is a variable. You see, you change parameters and the font changes continuously. This is not Knuth, this is Google. And let me show you something. I hope I can do it. Here it is. You see, you don't see my screen. Too bad for you. So I continue, sorry. I thought you would see it. Anyway, I wanted to show you a very simple box. In this box, you write any text. And on the right side, you have a lot of buttons. And we change the button. You have, in my example, 6 or 7 buttons. And each button changes continuously the font. It's something very useful and I think beautiful. Anyway, you have to think that this great Torniello or Dürer had one font, maybe 2 fonts, and now we have an infinite number of them. Well, finite dimensional, but fine, infinite. Let me show you something else that I like very much. Not very well known. Look, these are 7 letters E from Knuth. The size goes from 5 to 25. Of course, 25 is 5 times higher than the 5, but I zoomed in such a way that all these 7 letters have the same height on the screen. And what you see is that they are not the same. Many people believe naively that if you go from a letter 10 to a letter 20, it is just multiplication by 2. This is not the case. Why it's not the case? Because our eye is more sensitive to the size. Look, for the small one on the left, it's thicker. It's thicker because for small letters, we need more thickness. For big letters, we need less thickness. And this is completely included in the in the MetaFont program. So letters depend on the shape. I think it's something very, very interesting. Okay, let me finish by some political into quotes. Each country has its own way of drawing letters. I put some letters. The Italian like to be seen. So Bodoni, if you look at the font Bodoni, it's like, look at me. The French Dido, we like rules in our country. In Germany, there was this big artistic revolution in the beginning of the 20th century, Bauhaus. Letters have to be useful. For example, some fonts decided no capital letters. We don't use capital letters. Why is it useful? England, you have tradition. This font Caslon has been used for many years by the British. Letters are transmission. And for the US, I chose Gotham because letters speak to everyone in principle. Look at this one. I told you the king, Louis XIV, decided font for him. Well, my king, Macron, commissioned, it's not a joke, Macron commissioned a font in 2020, in the middle of the COVID crisis, and they produced this font called Marianne, and officially all ministers, all production of the ministers have to be printed in this font, which I think is ugly. Gotham, do you know this font? Gotham was the font used by Obama during his campaign. And more recently, it was also used by Trump during his first campaign. So you see there is some kind of concept that letters are useful when you look at them. And then you probably read in the New York Times recently a few interesting articles, like, for example, the change of the official font for the government. Usually it was Calibri, and it was forbidden recently, 2 weeks ago. And now the government has to use the font Times New Roman. I think it's something really impressive. And before it was Courrier. So people say that Calibri is more woke, maybe. Anyway, I recommend strongly this paper published in the New York Times 2 weeks ago. It's a wonderful paper explaining what I try to explain to you today, that a font is carrying culture. And you do not read poetry or history or mathematics in the same font. And I'm almost done. I want to finish by this new police, this new font. You know, the font Baskerville has been produced by Mr. Baskerville in the 18th century, but he forgot to mention that he had a wife. He had a wife, and his wife was his collaborator, and as far as I understand, did as much as he did. And somebody produced recently a font, which is, I forgot the name, I'm sorry. You have here some examples. You see this is a font which is mixing letters in order to mix masculine and feminine, like this is in French, of course. Anyway, I'm finished. I just want to say that we have seen that the humanists searched the beauty, and they found it somehow. But now we are happy because of computers, because of mathematics, we can have many different possibilities for many different shapes of letters. We do not write with the same letters for poetry, for mathematics, for novels, for posters, for GMM. And that's interesting to see that we try to understand how a font influences our way of perceiving a concept. So I believe that we should love letters. And letters, I like to say that letters are the guardians of history. Without letters, we would be nothing. Really, letters are the guardians of history. Thank you very much. No, I'm almost finished. I want to show you something else. Oh, look. 1 year ago, a friend of mine told me, look, there is a gallery in Paris, a contemporary artist has an exhibition, and the exhibition is called Diffeomorphism. So I went there, I met the guy. This guy is famous. He's a very rich man. He's a contemporary artist. He spent most of his life in New York, and he's producing diffeomorphisms. How does he do? He asks a mathematician to choose a text, and then he deforms it by a diffeomorphism. And he doesn't care about being beautiful, not beautiful, it's a concept. And the point is that he knows nothing about mathematics, nothing. And he knows nothing about diffeomorphisms. Anyway, he's a rich man. Thank you.
Thank you. What a fantastic talk. We have time for maybe one or two quick questions. You know where the mics are. So please go first.
First, thank you. This was a wonderful talk. Many of us in the room probably have copies of Knuth's multi-volumes, and we spend a lot of time getting stuck on those 40 problem exercises.
Congratulations.
While you're doing that, I would like to throw in, I'm not working for him or anything, but Donald Knuth also has another book called Things a Computer Scientist Rarely Talks About, and he talks a lot about typography and calligraphy and many of these aspects. And I read this book probably every couple of years, so I would just like to recommend it to everybody here. If you liked this talk, you'll like that book.
I read this book, I love it too.
Yeah.
I love this man.
How can you not?
Maybe one more, okay?
Yeah, this is also just a comment. Donald Knuth introduced tech at the Josiah Willard Gibbs lectures for the AMS. Can't remember whether it was a summer or winter meeting. I think it was in Colorado, but I'm not sure. And he spent about 15 minutes on tech, which then became the language of mathematics. We immediately started using it in email, and it improved communication because of the ASCII aspect. But he spent the other 45 minutes of the talk on the fonts. And I have to say, I myself went back home and I designed a square from that font. I was very proud of myself. Everything that he's done has been beautiful, but of course, he owes it to all these other clever people who designed letters.
Maybe I could quote a last quotation of Donald Knuth. He wrote the following: I suppose that I have ink in my veins. When I discovered the potential of digital printing, I couldn't resist putting the rest of my life on hold in order to adapt the typographic wisdom of the past centuries to the opportunity offered by our time. He's a really fantastic man.
I'm grateful to him because my dissertation had subscripts and superscripts, and my subscripts and superscripts, so without tech, I would have been in trouble. Maybe we have time for one more?
So you told this story about the mathematician Jacques Tits,
Yeah.
How he received this plaquette from very good mathematicians,
Yeah.
and how he changed traditional mathematics. But mathematics is changing very fast these days.
Too fast.
It's gonna keep, the pace is gonna increase.
Yeah.
So my question is, how do we create new tradition in mathematics? It's not the beauty of mathematics that we do because it's subjective. It's not the truth of statements that we produce because it's
If you want my own opinion, we should slow down. I've been doing mathematics for many years now, and I lose control. When I was a student, I had the feeling that I had a global perception of mathematics. And today, looking at the program here, I'm lost. And I hate that. So I think mathematics is in great danger because of this explosion. This is my own opinion.
Please join me again in thanking Porter Lecter.